Sure, it's fun.
Okay. I'm just going to walk through a couple of just slides about the next meetup and stuff.
Sure.
Just a few minutes. Okay, cool. We'll go ahead and get started. I appreciate everybody who made it. Here's the link to the meetup in case anybody hasn't had a chance to join or RSVP. It certainly helps when you do, because then I can make sure that I have enough food for everybody. So, I'm Ben Rodrigue, organizer. This is Carlos Camarillo, co-organizer. And our sponsors this month are Geekdom for providing this awesome space to get together, and then Cumulus Technologies, which is a CTO of Cumulus Technologies, is a friend of mine, Robert Starmer, and he's not here. I could talk a little bit about his company. Essentially what they do is consulting around cloud, migrating to the cloud, migrating applications to the cloud, helping people basically get ready to move to a public cloud or deploy their own private cloud, whether it's OpenStack. He likes to stay on the bleeding edge, so Kubernetes. He does a lot around Docker and containers, whether it's on top of OpenStack or he's on the bleeding edge though. So what a lot of people utilize him for is getting teams up to speed on cloud, and then he does a lot of trainings too. So a lot of ongoing training engagements around getting teams ready to deploy OpenStack. He did a lot of training with a lot of companies that are out there, Time Warner Cable, Cisco. So a lot of their teams that are deploying OpenStack and are ready for OpenStack. It's due to his hard work. So that covers Cumulus, and then obviously our 7 o'clock talk is Matt Dorn from Rackspace. And what we're doing is a 2-part series on passing the Certified OpenStack Administrator test. Whether you plan on taking it or not, you're going to get a lot from these next 2 talks. This one is going to be a high level of OpenStack overall and the OpenStack projects, how people are utilizing it. Matt being a Rackspace technology trainer, this is what he does every day, so he lives this stuff. So if you have questions that aren't getting answered as he's walking through, I'm sure he'd be happy to field any questions that you have along the way or after the talk. And then the second talk, I should jump over here, on July 14th is the second part of the series, and it's going to be more hands-on. And that's what he was referring to the file. That's what he was referring to. So you can set up a virtual lab environment and then basically administrate an OpenStack cloud from the command line. Being comfortable administrating OpenStack from the command line and the GUI should put you in a really good position to be able to pass the Certified OpenStack Administrator test, should you choose to get that certification. And then on August 11th, Brent Clements with Canonical is going to be talking about architecting the telco cloud. Essentially, telcos are early adopters and large adopters of OpenStack, largely so they can, it's in terms like NFV, Network Functional Virtualization, SDN, Software-Defined Networking. They utilize those to essentially set up virtual networks around the country, around the world, where traditionally they have hardware with embedded software providing all these this network routing around the country, and instead their software is eating everything. Software is eating their network, and so now they can deploy networks, just remote, and they're not sending people out to plug switches or reboot servers or anything like that. Everything's virtual. And so he's going to talk about that. And with that said, we'll introduce Mr. Matt Dorn, our speaker. Any questions or anything?
Yeah. guys. How are you doing? Pretty good. Okay, so what we're going to do is we're going to go through this is like the biggest high-level overview of OpenStack that you probably, well, if you don't know what OpenStack is, or maybe you've heard of it, this is a good thing. Okay, if you're a little confused about what it is, you've heard a lot about it, you know there's a lot of hype about it, this is definitely a good talk to check out. So this is going to be called a tale of two clouds. And what we're talking about here are two very specific clouds, and there's a lot of confusing stuff out there about this, but hopefully this will clarify things. So, just to show of hands so we can get a kind of a feel for where you guys are at. How many of you use VMware? Okay, cool. What do you use, like Workstation, vSphere, vCenter, something like that? Okay, cool. How many of you use Amazon Web Services, AWS? Okay, so if you already know AWS, you're already very far ahead of the game. And how many of you currently use OpenStack? Okay, so if you already know OpenStack, you're probably going to think, oh man, I already know a lot of this stuff, but it's good just for a review. And how many of you feel comfortable on the command line? Okay, good. It's okay if you don't. Like, how many people in here prefer GUI over command line? GUI being the graphical thing you click in? Yeah, it's fine. It depends on the situation, yeah. Okay, so a little about me. I'm an OpenStack contributor and technical trainer. Maybe I can hold this thing here. Am I in the right? Should I move somewhere? What do you think would be good for the?
You're fine. I can see your face wherever you're at.
Okay. Cool.
I've got the whole stage. So.
Okay. Nice.
I could zoom in for your close-up if you'd like.
Yeah.
Just tell me when you want to be dramatic at all.
Yeah, I like that. Okay. My LinkedIn is Matthew Dorn, so if you want to go, if you wanted to force you to endorse me for something, it just seems like every time I log into LinkedIn, it's trying to force me to endorse someone for something. My GitHub is MA Dorn. My IRC is Freenode. Are you guys on IRC? Cool. Freenode. Awesome. And my email is matt.dorn@rackspace.com. And you can send me an email anytime. If you have any questions or anything, just always send me an email. I'll respond to every email. So I'm assuming probably a few things here. I'm going to assume that we all sort of understand the benefits of virtualization. Do we know what it is? We know how it's helped people out. We know that cloud is definitely an overused buzzword, right? You have marketing that looks like this, with somebody on a mountain, and there's clouds, and it looks like he's trying to get a Wi-Fi signal. But, you know, it's kind of like it's just sort of it's marketing fluff, right? So what is this thing we're talking about? Whoa, before the cloud. This is before the cloud. This is a little before my time, to be honest. Maybe some of you remember this. Before the cloud, we had to do something, right? When you're a software developers, if we were going to talk about this from the perspective of the software developer, not the network engineer or hardware engineer or anything like that. This is the person who actually develops apps, right? The person who develops apps because they have a job that pays them to develop apps for them that save them money or make them money or whatever, right? So this is told from the perspective of the software developer. Once upon a time, you had a software developer, right? And they created an app, maybe locally on their machine, and they wanted to put that on something, right? They wanted to put that application. They had to put it somewhere. They had to put it on something so the world can access it, right? So they would have to call up on the phone someone, Dell or HP or someone, and actually say, hey, I need a server. And they would get a physical server, and they would put their application and their database on that one physical machine. Right? So do you see, this seems ridiculous now. You look at this and you're like, who the heck would do that, right? But the reality is that at some time someone had to have done this. Someone had to have been the guinea pig, so to speak, to actually try this. I mean, what's the clear problem with this here? I mean, the clear problem is something is going to happen. A motherboard's going to go dead. Something's going to, a RAID controller or something, maybe that wasn't even that popular at this time, but some piece of hardware is going to die. Something's going to happen. The thing is going to fail. And it probably did fail. and the software developer got a call in the middle of the night, and he was, completely angry, and the hardware guy was angry, and they're yelling at each other, the application's down, and no one can access it, and this was a nightmare. So then they thought they'd get a little smarter, and they would go and buy another physical server, and put the database on that. And so if there's any problem with the database, we're okay. But obviously, we can tell what's going to happen here. Still, single points of failure, right?
It doesn't work.
What's that?
It doesn't work because now you have like 2 different points that can fail the whole thing.
Yeah, you're exactly right. It's even worse. It's even worse. So they said, okay, we're going to fix this thing. We're going to get this thing called a load balancer, and we're going to have the people access the load balancer, and then we'll buy another physical machine. We'll put that behind the load balancer. And so if one of these machines goes down, we'll be covered by this one, right? But we forget about the database server here, the single point of failure. So then we go and we call up Dell, and we order another physical server, and we replicate our database to that server, to that new physical machine, and we think we're covered here. I mean, we're like, this kind of works. It works, right, until the application gets more popular. More people start hitting this application. Let's say it's advertised on Oprah or some TV show, my application's on the Super Bowl. More people are going to start to hit this thing. They're going to start to access my website.
Was Slidewell not invented yet?
What's that?
Slidewell was not invented yet?
I guess not. And so most people are starting to hit this thing, and what's actually happening, the more people hit my web application, what's going on with these physical machines? If we were to go into these physical machines and we were running Windows, we were running Activity Monitor, or we were running HTOP, if it was Linux, something to view the resource usage, what would you probably see on these physical machines as more people are hitting them? What would you see? Any guesses?
Overheating.
Yeah, overheating. Yeah, if you looked at the CPU overheating, what else? What else would be crawling up, getting larger, 40, 50, 60%? CPU usage, yeah, exactly, yeah. Just I/O, it's going crazy. We need some more physical machines behind this load balancer here. So then we go and we get some more physical machines and we put them behind the load balancer. We get more load balancers too, some more firewalls, and things are really getting crazy here. We're just always buying more physical equipment. And not to mention that what happens when my app gets less popular? What happens when there's a time, maybe during the summer, when my app isn't as popular because not as many people are hitting it? It's not like I'm going to go to the data center and retire all these servers, right? I mean, I guess I could and wait for the next time it loads up, but then I forget about the fact that I have to replicate this whole thing to a data center because a hurricane or something like that, right, may come and blow everything away, and this is just awful. Anyone ever have to put together a disaster recovery plan or anything like that? It's pretty awful. So this is the nightmare, right, of physical gear. This is the nightmare of physical gear. And then in 2003, something happened that really revolutionized everything. Now, I'm skipping over a great deal of things. I'm skipping over, when people actually start utilizing virtual machines, but I'm going to just say something that maybe I would have a problem with, but VMware really brought virtualization to the mainstream. And in 2003, something came out that really changed everything. And that was, this is an actual press release, by the way. This is an actual press release from VMware that says, VMware Incorporated, the global leader in virtual infrastructure software for industry standard systems today, announced the availability of VMware Virtual Center featuring vMotion technology enabling the management of a virtual infrastructure for the responsive enterprise. So anyone here ever heard of vMotion? Yeah, so it was pretty awesome, right? I don't know if you remember when this thing first came out. It's still pretty awesome. But when it first came out, it was incredible. They used to have these demos where they would actually show a ping, and then they would bring down a server and the ping would barely skip a beat and it would just keep on going. If you don't know what vMotion is, it's totally okay, because I'm going to show you what it is. In case you don't know what it is, this is why it was really awesome. So with vMotion, you have these things called hypervisors. And if you're unfamiliar with hypervisors, think of those as the things that are actually hosting the virtual machines. And these applications, I have a database here, these little individual OS, these little containers things here, these are virtual machines, okay? And we have, obviously we're using the ESXi hypervisor. And we also have a shared storage between all these things. So the little VMs that are running are all sitting on shared storage. And guess what happens if I go behind the first hypervisor and I pull the plug on that hypervisor? Let's just say that that hypervisor went down, the motherboard died. Let's imagine my web application or my web server is sitting on that virtual machine. It could magically move to the other hypervisor without any downtime, which means I'm not getting a call in the middle of the night. If I'm a software developer, no engineers are calling me. No engineers are calling me and bothering me saying, your app's down, okay, we have to fix the server. And those two virtual machines move over elegantly. They just transfer over just like that. I get no call in the middle of the night. Now, this right here, vMotion is just the technology that VMware kind of used, but there's a whole suite of VMware products. All very, very expensive products, you know, lots of sales guys going on to expensive steak dinners, signing contracts, selling lots of VMware. And there's something called like Site Recovery Manager, VMware Data Protection, Distributed Power Management, a whole bunch of different products that they have, right? So this kind of stuff is typically what we find, at least at Rackspace, at majority of the customers that we go to. Big customers, right? Big enterprise customers, Fortune 500s and all that. They have this sort of model here, which is what we call the enterprise virtualization model. Enterprise virtualization. This is also known as Mode 1. Gartner, you guys know the Gartner research group? They do like, a lot of IT space research, and they call this Mode 1. A lot of people have issues with this. We don't have to get into that now. But we call this enterprise virtualization or Mode 1. It has some very, very, very distinct characteristics. Some very distinct characteristics. The first one is that it's typically GUI driven. So those of you who have used vSphere, maybe you've even had the nightmare of using vSphere web client. Okay, you log in and the wheel is turning, and then you're finally logged in, and then you click on a drop down and it's like turning the wheel, and it's awful. When you want to create a VM or do something like that, you right click and you click on new and you want to do different things, and it's just very, very, it's very clunky. I mean, sometimes some GUIs are nice, maybe if you use the actual vSphere client, not the web client, but still, it's very, it takes a while to do what you want to do. Ticket-based. Most of these organizations are insane. I don't mean to talk bad about other organizations, and it's not like that. It's just that they're operating at such a very, very slow level. Like, for example, if a web developer needs to get a server up and running, they have to put a ticket in. And that ticket takes days and days, sometimes, for them just to get that thing provisioned. They're waiting for a network administrator or system administrator on the other side to pick up the ticket, to go and create the VM via the GUI, and it just takes way too much time. Not to mention to open a port 443, port 80, the time it takes to do that. They have to open a ticket for all that stuff. Scale up. You'll hear about people talking about scale up all the time. When we talk about scaling up, what we're talking about is adding more CPU and RAM to the individual VM itself. In other words, if you can visualize yourself logging into vSphere, even if you've never used vSphere in your life, you see a VM. You notice that the CPU threshold, it's using a lot of CPU. It's getting up to 60, 70%. You right-click the VM, you add more CPU, you add more memory. That's scaling up or scaling vertically. Very different than scaling horizontally, which is where you actually have access to as many VMs as you want, power a little differently. So keep that in the back of your head. Scale up, adding more CPU and memory to an individual VM. Smart hardware. In this model, companies have spent a lot of money, on hardware that serves a distinct purpose. We're talking about crazy, crazy expensive blade servers, maybe servers that have a crazy amount of redundancy built into the hardware. Very, very expensive stuff. So hardware that serves a very, very specific purpose. Proprietary. Typically in this model with proprietary, the code is not open source. It's not a bad thing. I mean, it's just that there's a monolithic one organization that controls the code. And because they control the code, if you, the consumer, find a bug, find something wrong in the code, let's say, for example, every time you go and upload a file via the vSphere client or what have you in your web client, it times out, and there's no way for you to actually go in and reset the timeout as a configuration option or make the timeout longer. You have to file a bug with VMware, and that could take a very, very long time. Okay? That could take a very long time depending on their turnaround. And then here's the most important part. The most important part here is traditional software development. Meaning that the developers who moved, who once created applications that got put on physical servers, are still developing those apps as if they were, even though they're using something like VMware, they're still developing the app in the same way. Okay, it's not going down, they're not getting calls, but they haven't changed the way that they traditionally create the app. They still just have a web server, they might have a database, they're using very older frameworks. Their methodology is the same. They haven't changed that methodology. So that's significant because something very, very important happened in 2006. Anyone know what it was? 2006? Anyone remember what you were doing in 2006? Any guesses? Okay, I'm going to show you this. This is an actual press release from, this is Michael Arrington of TechCrunch, popular blog, and this is before AWS, by the way, Amazon Web Services. You don't have to know what that is or anything. But S3, something called S3 came out. And the reason why this was so awesome, you see reading this here, it says simple storage service, a storage service backend for developers that offers a highly scalable, reliable, and low latency data storage infrastructure at very low cost. What it was the ability for a developer to take a credit card and put the credit card on file, and you could store as much data as you wanted to in, let's say, the cloud or in a remote location, but you could do it via a SOAP, that's a type of API, SOAP or RESTful API. That's, an application programming interface that developers love to interact with. You could use a SOAP or REST API and store as many objects as you wanted, static objects. What am I talking about here? I'm talking about CSS, JS, HTML. You could put as much of these as you wanted, and you just pay for what you use. And guess what? It's super cheap. Extremely, extremely cheap. So this was really game-changing for, think about it, maybe perhaps young developer, she's perhaps maybe just living at home or living in a dorm, wants to create the next killer app or something. This is pretty cool. But it gets even better later that year, in August of 2006. In August of 2006, they actually come out with EC2. EC2, which is actually the ability to spin up a VM with, or via, I should say, a RESTful API, okay, or SOAP API. This is extremely powerful because the same concept kind of exists where you put your credit card on file, but you can spin up as many VMs as you want. Now, it's important that we understand that from the user's point of view, you're spinning up as many VMs as you want, but from the operator or Amazon's point of view, they obviously have to be very aware of the consumption, right? So I want to make sure we understand that in this case, there's the person, the software developer, that is using this stuff because they want to create an application, and then there's Amazon who's actually hosting it, right? They have to be very aware of how much people are using, how to actually expand it out, just put more servers in the data center, all that good stuff. But anyway, you get the idea. Because what this really does is change the whole model. This is what it was doing at the time. No one had any idea what was really to come after this, because this is providing power to developers. Because developers, they build applications, right? They don't really manage the data center at all. So they can quickly scale the application during times of success. That's when your application gets really, really popular. All you have to do is spin up some VMs, you're spinning them up, And then if something fails, if a VM fails, if something happens, You can handle that elegantly because you have built redundancy into the software. You've spent time to say, if a server dies, go ahead and spin up another one via an API call, and whatever service was running on there should be able to run on this as well. Okay, it's not going to actually destroy your application based off the way you've developed it. Now, this really is the second type of cloud, or as Gartner says, mode 2 type of cloud. It's typically API driven. Okay, so we have application programming interfaces that we can interact with, super powerful stuff. All right, we can do it via that RESTful API. We can talk to that via the RESTful API. And you guys all know, even if you're not a developer, if one of your friends, you guys go to dinner and they're talking about how great the fact that Instagram has an API is, or Facebook has an API, just understand that that means that they can actually programmatically interact with that service, like Instagram, and create an application that takes advantage of something a feature of Instagram, right? It's pretty cool stuff. Self-service. What is self-service? Self-service means that you don't have to wait typically for a ticket. Think about this. The only thing you really need to do if you got hired for an organization that's using Amazon is just ask really your new boss for the username and password to log into the control panel, or your username or so you can get your token and all that good stuff, right? Your API key. So you don't have to generally create tickets and do anything like that. It's self-service. Scale out. What do we mean by scale out? This is different than scale up, right? Remember, from the software developer, the person who is actually developing the application, the person who's developing an application on Amazon, from their perspective, they can spin up as many VMs as they want. And because they can spin up as many VMs as they want, they're not going to bother with adding more CPU and RAM to an individual VM. Just spin up more instances, because instances come and go all the time. You can spin them up, you can shut them down. The process is so quick. Standard hardware. Standard hardware. So what does standard hardware mean? Standard hardware means basic, standard. Doesn't mean like an old, like beige Athlon XP from the Salvation Army or Goodwill or something. We're talking about just a server that serves a general purpose, not a specific purpose. Not the latest, greatest blade, but if you can imagine just a rack mount server that is very good for many different uses, not just a specific thing. Because remember, we don't need all that hardware redundancy and all that hardware that serves a specific purpose. The redundancy is going to be built into our application. And typically open source. Now, Amazon is not open source, but an Elastic Cloud or Mode 2 Cloud that we're going to learn more about, coming up here, is typically open source. And if you're looking for the correlation between sort of open source and Amazon, think about all of the startups that started using Amazon. When Amazon first came out, why would they use Amazon? Because it was cheaper than having to go buy physical machines, which was pretty cool. And those same organizations, you think they're going to pay for commercial licenses of Microsoft stuff and IBM WebSphere and all that? No, they're going to go and they're going to go open source. They're going to get involved in the communities, and they're generally pretty tech savvy. So they're going to figure out how it works, even if there's not a lot of documentation on it. Maybe they'll even end up contributing to the documentation. So it's a different culture all around. And then cloudy development. Cloudy development. So this is the one part that a lot of people get confused about. Is that, remember in this model here, in this traditional software development, we were still developing on this vMotion, we're still developing our applications as if we were living in a bare metal world, a hardware world. Well, here, we completely changed the way that we develop our application now that we have access to this stuff that allows us to fire off VMs in a second. So, what this really is you might have heard the analogy, it's been around for a long time. In fact, it's pretty outdated at this point. And a lot of people would even say this whole kind of thing is a little outdated at this point, but I think it's a good intro. We say this is kind of a hot rod versus rental car mentality. So think about, we also call pets versus cattle. So think about a pet. You take care of it, right? You feed it. You give it that, you know. Hot rod, you take care of it, you know, you would never do anything, you know, you want to take care of it, make sure it's always running properly, you give it a car wash, all that stuff. It's kind of like how we treated our old hardware. Rental car is, I don't know about you, I mean, you know, when you're in a rental car, you kind of treat it a little differently, right? I don't do anything crazy, like, you know, but the reality is that if something happens to it, you turn it in, and you can get another one. Same thing with this concept of cattle. I know it's kind of more, it's like we're in Texas, so I know it's a little morbid, but with cattle, you know, when they say they get sick, what do? They just kill it. It's the same thing with these VMs. Something doesn't work out, something's not working right, just get rid of it and spin up another one. But what we want to focus here on is what we're talking about in terms of cloudy development. Cloudy development. So when we're talking about cloudy development, we're talking about techniques that you use if you're a software developer and someone says to you, we have an Amazon cloud, we have an OpenStack cloud, we have a cloud that you can use for developing your applications. And I'm all about it because I know it's going to be very, very fast, a lot of agility, I can get the thing up and running, but I'm going to design my application a little differently. So here are some of the characteristics of what a developer should use to actually use that cloudy development model. Okay, so best practice number one for developing a cloudy application is to break the app into pieces. And this is there's lots of buzzwords around this. Sometimes people call it microservices, okay? Sometimes people call it, there's some other microservices, componentizing, breaking it into little microservices. So look, here's the deal. Identify your node types, depending on what kind of application you're going to build out. You're going to do a web server node, obviously. And this runs a web server. What do you think this would probably run? Just guessing. IIS? Yeah. Apache, yeah. Apache, IIS, Nginx, right, which has been pretty popular lately. It may leverage a particular framework. Think about a framework. Framework like Ruby on Rails, Grails, Django, right? These are web frameworks. It serves the user interface, so usually the primary gateway for a user that they're going to interact with. You may have a service node that's only accessible by the web server node, so it's not externally accessible, in other words. Specialized to deliver discrete functionality, and it's stateless and autonomous, which we'll learn about in a second. These are new words to you. Data node. It interacts with the data store. It reads only from the web server nodes, and reads and writes from the service nodes. But not only that, when we actually get in, when we're talking about microservices, what we're talking about is you can visualize this service node. It's a monolithic service node. You're saying node, what are you talking about? I'm talking about, it could be a given VM, it could be a service. It's something, or a daemon, and if you're unfamiliar with that, it's a running program, a running process. So what's going on here is you have the service node, you would actually break this into pieces. You could break it into actually having a registration node, billing, auth, and report. So let's say all of these different features are available in that service node. You could just break them apart because maybe on a certain day, let's say on the last day of the month, your billing node, your billing service that was part of the service node goes crazy. Well, you know what you would do? Just scale out your billing service. Just scale that part out. So really how you break these up, it depends on how you're going to actually scale the app and how you split them up visually. It's just a matter of customizing it. But understand that we have microservices so we can easily scale up when we get more popular, and it also helps with redundancy too. Now, everything that I'm showing you here, again, is I'm showing you techniques that a software developer would use for developing on a platform like Amazon or OpenStack. But guess what the big secret is? The big secret is that all these techniques I'm showing you are actually utilized by the platforms themselves. And by that, I mean Amazon, the actual infrastructure, uses techniques like this. OpenStack uses techniques like this. All right? So you could say that Amazon was built for cloudy applications, for people to put their cloudy applications on there, but in itself it's a cloudy application. Same goes with OpenStack, which we'll learn about where OpenStack came from in a second here. Another best practice here, we have loosely coupled and autonomous. Has anyone here heard of AMQP or Rabbit or a messaging bus? So a messaging bus, you'll see it all over now. It's super, super popular. I mean, what the whole idea is, look, if you're spinning up these nodes, right, or VMs or services all the time, you're bringing them up when you get popular, you're bringing them down when you're not as popular, you're bringing them up, bringing them down all the time. You don't want that VM to have to know about all the other VMs in the organization and have to somehow introduce each other all the time, have direct concurrent connections. What you do is to eliminate that chaos and that mess, is just create one message bus and simply point the service or the VM, whatever, to the message bus. And then, for example, the web server node will put a message on the bus, and the report service node would consume it. So each service just has to make sure that it points to the bus for communication. This really eliminates a lot of the complexity. Now obviously it works, it's more complex than this, okay? But understand that that message bus typically is clustered, all right? It's not a single point of failure. Typically it's clustered, all right? But the point is that when you bring a VM up, or you bring a service up, and you want that service to communicate with your other services, you just have to ensure that that service has the message bus IP address, or multiple IP addresses if it's a cluster, and usually a username and password, so we can authenticate. All right, so it makes communication amongst different services really easy. Examples of this are something like RabbitMQ, which is really popular with OpenStack. Cupid is another one. Best practice number 3, instance personalization. So what we have to do is kind of think about the instances as kind of robots reporting for duty, going through an assembly line of some sort. So when you go and you spin up an instance, you don't have to bother with SSHing into that instance and installing everything, right? So you basically spin up a VM, and the VM asks, who am I? It gets a host name, it gets an IP address, it grabs an SSH key. If you're not familiar with SSH keys, just imagine there's a public key and a private key. You hold on to the private key. You don't show anyone, right? Where's the public key go? On the VM, right? So you can SSH into it. Update DNS, so you can resolve a name to an IP address. Mount a specific EBS volume. If you're unfamiliar with EBS at this time, that was elastic block storage. It's comparable to Cinder in OpenStack. It's basically like a little miniature USB drive that you plug in to your VM. And all of a sudden, if you're on Linux, you have a VDB or VDC. And if you're on Windows, you have a D drive, right? Where would you see that? Like in disk management, remember that little balloon in the top right would pop up? I don't know if they still have that in Microsoft, but install Apache. Install Apache. Automatically go and install Apache. Opens up port 80. Copy some files it needs from S3. And then start all the services and the thing's ready to go. Now you may be wondering, well how did you get it to do all this? This is time that you would take to create a script. It can retrieve all this information, like its name, or an IP address, or a key from a metadata service that exists in the environment, from a metadata service. The type of metadata, Amazon has a metadata service, Google Cloud has a metadata service, Azure has a metadata service. We'll learn about those a little later, but understand that there's something in the environment that allows us to retrieve that actual information, okay? And then best practice number 4, elasticity and autoscale. So many of you may have heard about autoscaling before. What happens is your app gets more popular, the CPU is going to go up, and what it does is when the CPU reaches a specific threshold, it kicks off an API call that spins up another VM that throws it into the same group. And that reduces the load on that server. And lastly, things work better in parallel. This is that horizontal scaling thing we were talking about. So imagine that you're a farmer and plowing your land with one plow takes 5 hours. Okay? Plowing your land with 5 plows takes 1 hour. So just spin up more VMs. In this case, imagine we're converting like an MKV to MOV or ABI. I could, rather than have to, it's taking a long time to render, I could technically spin up more transcoding servers or more servers and point them to my file. Let's say they're all using an NFS share. I have all my files in an NFS share, and I have some kind of batch processing where I can actually utilize the power from these other servers here to do that job. Because from my perspective, I have as many servers at my disposal as I want, as many VMs as I want. And so at this point, this is 2006, 2007, 2008, people are adopting these cloudy techniques, and everyone's spinning up VMs, and everything's great. But then here's the reality, people start getting a little scared. They start getting scared because they're locked into Amazon. They're locked into using Amazon's API. If Amazon wants to change their API, they can. If they want to jack up their rates, they can. And people start thinking, there's got to be a way for us to create something like Amazon, but open source. An example of this really is the fact that if my entire team has they've spent months and months and months coding, all right, to Amazon, I'm not going to be able to take that work and easily point to another cloud, like Rackspace, Azure, Google. It's not going to be easy. Now, I guess you can start to think that if we, creatively, if we were trying to think like, well, what if we created an open source platform or open source operating system that had a universal API, and people all around started adopting these clouds in their data center, it would be very easy to move between clouds. They're all talking the same language, so to speak, or all using the same API. So this is in 2009 when the open source cloud war sort of begins. And we have this cloud stack, OpenStack, OpenNebula, and Eucalyptus. These were the four primary sort of clouds that were battling each other, starting from 2009. You can see here Eucalyptus and OpenNebula. And they're battling each other, and we see that clearly 2010, 2011, OpenStack takes off. What you're looking at here is the number of monthly participants. Okay, so what this literally means is that when these clouds were out, I don't think you could probably get a job back then, full-time salary, contributing to one of these open source clouds here. Really unlikely. So that means that people were actually spending their free time at night, the weekends, coding to a project. That was part of their, despite their full-time job, they're working on this stuff. I think, that one of the reasons why OpenStack sort of took off here was really because there's some major companies got behind them at this time, 2010, 2011. I don't know about you, but if I were working on this project on the side, and I were deciding, should I start coding with, to OpenStack or CloudStack, or to CloudStack, OpenStack, OpenNebula, I probably am going to side on, personally, I would work on whatever language I was comfortable with. Python's pretty accessible for a programming language, but you're probably going to start working on whoever has the big players behind it, right? It kind of shows longevity, kind of shows it's going to be around a while. All right, so that's what you're looking at here. So just to kind of, I want to take any questions that you guys have. I don't mean to rush through stuff without questions. We have plenty of time for that. But I just want to show you something really quick to help solidify a lot of confusion. If you're not confused already, just really, really quick. There's basically three flavors or three types of OpenStack. And I mean, this is the way to think about it. You have the OpenStack project. The OpenStack project. This is the project that actually lives on GitHub. Okay, it's the project that lives on GitHub. It's at github.com/OpenStack/ and the name of the project. These are projects like Neutron, Glance, Nova, Cinder. They're all in GitHub. All the code is there and visible. That's the project. Everybody's contributing to it. Everybody's working on it together. Okay. You can also, you'll see links sometimes to git.openstack.org and review.openstack.org. Understand that there's mirrors of this upstream code, and we use that term upstream. Okay, that is the actual code there, the OpenStack code, that is mirrored to these locations. So if you see these, understand that it is mirrored there. Then there's the product. So people have to make money on this thing somehow, right? The OpenStack product is actually taken from the project. They take the code from the project, and it's their own opinionated way to deploy it, the way they think it should be deployed, with what tools, with what hardware, and then they wrap it usually in a support model. So they actually say, okay, you know, you gotta have this hardware, you have to use this tool to deploy it, and if you have any issues or anything, you can always call us up for support. And it can be in your data center or ours. And for example, Rackspace has a product, ours is Rackspace Private Cloud, Red Hat has a product, Mirantis, a very popular OpenStack company, has a product called Fuel. And then there's a service, which is cloud servers, for example, public cloud, right? Something that everybody has access, something that everybody is sort of accessing, right? I mean, if you think about our public cloud, anybody ever used our cloud before, our Rackspace public cloud? Yeah, so you got tons of people on there, you got competitors sitting next to each other, Burger King, McDonald's probably sitting on the same physical server, they don't even know it, right? So, this is kind of a loose kind of story breakdown of how we got to where we are today. So, and do you guys have any questions so far? Yes.
I think one of the slides, it was me.com was mentioned as a domain name. Does Apple use OpenStack?
Me.com?
Yeah.
Where'd you see me? Where'd you see me.com?
I think like in one of the slides that you were showing, there was a domain name
Let me see.
under
You
me.
changed it around provisioning the
It
servers.
was when you were explaining the messaging queue, the bus system.
The instance is a robot.
Yeah.
That one there,
Yeah, this one.
no.
Oh, me.com. Yeah. Okay, you're talking about this one right here, right? I
think
don't know
it's
why.
like all-
I don't know why I used me.com. Is Apple still in that?
Yeah, of course. That's
No,
that's
I don't
what
use- I
the
don't use that.
email address is.
I don't know. I didn't know that. I don't know why I did me.com. I don't know. You should change that.
They might.
What do you think I should change it to? What would be a cooler thing?
Example.io, example.net.
How about Contoso? You know that as Microsoft. Microsoft uses this thing called Contoso, like all their examples were like Contoso.
Geocities.com.
I like GeoCities, yeah. Yeah, I like
Angel Fire gets the glitter.
yeah. Yeah, I gotta change that. That's a nice eye. I like that. Anything else coming into your mind? Anything you're thinking about? Anything you're still, yes,
You said you're a contributor. What have you contributed to?
the manuals.
Okay. That's
Yeah, I do a lot of the manual stuff, and I work on actually making sure that when you go through the actual Ubuntu install, that it is clear, concise. We install from the Ubuntu packages, so if you actually go to docs.openstack.org, I can actually see if I can bring this up here.
And that still gets you a free summit pass, right? You're a contributor.
Yep.
Yep. So I've done a lot of work in the install guide. And as you can see, this actually teaches you how to install a 2-node, and you can see it from here, but a 2-node environment with a controller and a compute node. And all the network services are on the controller. Okay, so it basically helps you set that up, start to finish, via the Ubuntu packages. And here you can see you start with installing Keystone, Glance, Nova, the networking, all that good stuff. And it tells you which packages you have to install. And just so you know, what I did was I created on my, if you want to walk through this, it's a good idea, but I'm assuming that you guys just don't have some physical, I'm assuming you don't have just physical servers lying around, and that you're probably going to attempt to do this on something like VirtualBox, or VMware Fusion, or Parallels, or maybe if you're hardcore, maybe KVM, I don't know. The point is that if you do attempt to use VirtualBox or something, if you go to my website at madorn.com, go down a bit, for the Liberty install guide, and this should actually still be applicable to the Mitaka guide, this should still be applicable to the Mitaka guide. What you can do here is,
What are Liberty and Mitaka?
Those are the, good question, those are the OpenStack versions. So right now, we are working on the Newton release. And if you're just kind of understanding what that is, well, hold on one second. If you want to go through the install guide, check out this guide on how to easily set up VirtualBox to support the 2-node configuration that the guide goes through. Okay, so it's very straightforward. I have pictures on there. You know, for those, I think I have an arrow. I did that in Microsoft Paint, I think, or something.
It's custom.
Yeah. So, anyways, check it out. It definitely works. And to answer your question, let's hop right here into the code, and this will become more clear. If we go to GitHub/OpenStack let's go to manuals. You can see when you click on branches, you have 4 different branches. You have master, you got stable Mitaka, stable Liberty, stable Kilo. Master is Newton. It has not been officially released yet. It won't be officially released until the Barcelona OpenStack Summit, which is in October, I think. The previous versions are already out. Stable Mitaka, stable Liberty, and Kilo. So they're just older versions of OpenStack. If you're kind of looking for a big picture, let me show you something. Look at all the releases. I have a nice diagram here. Let me show you this. So these are all the OpenStack releases, and these are the dates that the summit actually occurred. This is the actual celebration for the release of that. So Mitaka, we were in Austin for the celebration of the release of Mitaka, and the crazy thing is that when these summits are going on, way back in the corner, amongst all the Red Bull and beer and Surge and all that stuff, there are people working on the actual code, on the manuals. They're discussing new ideas, discussing new features. They're arguing about IPv6 router configurations, Slack, doing all types of crazy, tons of crazy arguments. And it's a really fun thing to do and check out. So if you haven't been to a summit yet, you should definitely check it out. Probably hard if you go to the Barcelona one if you're not an active technical contributor, but they're definitely worth checking out.
It looks like the planning summit, because that was Japan was Mitaka.
Oh, that's right, yeah. So the Mitaka here, this is actually when they were planning it. Thank you for pointing that out. I didn't realize that. So, yeah, this was the Mitaka summit. We were in Japan. You guys were there, right? Yeah. And this is when they're actually planning the Mitaka release. Yeah. Yeah, thank you. Any other questions at all? I still have a little more stuff if we have more time to go through, but
Like the projects and stuff?
yeah. Anything else at all? Any questions? Anything you're curious about? Yeah.
Just a kind of side, bizarre question. You ever use Vagrant to set up your virtual boxes?
Yeah.
And how did you get past the issue in setting up the network routing and using 3 nodes? When I try and do it with Vagrant, it breaks it after I add the third node.
Depends how many interfaces you have in Vagrant. So Vagrant automatically, the first interface is going to be the one that you use for SSHing in. It's always like a NAT interface,
Right.
the first one. The second interface I use is a host only. So the first one I use is a NAT, and the second one I do is a host only. And on the network node, when you're trying to configure a controller, a network node, and a computer,
Right.
the network node I actually have 3. I have my first one is a NAT, my second one's a host only, and my third one is a NAT, which gets, the third NAT is the one that gets buried into the external bridge, so to speak. That's how I'm getting my router actually to the outside world.
Okay.
Okay, so, but I can help you after, just come see me, I'll map it out for you, and I can show you how you can do it, yeah. Yeah. Any other questions at all? Yeah.
This is my first time here actually trying to learn OpenStack. If you don't mind me asking about the slide, what is each of these, I guess OpenStack summits are?
Yeah.
Are they like different, not, what am I thinking? Oh, like are they updates or what are they actually?
It's two things. It's a convention, right? Where it's like we have all these different presentations. Some of them are really salesy. Some of them are actually informative. And then there's something else going on at that same time, which is Design Summit, where all the developers, the community that actually works on the code, they're having very important meetings about decisions, deciding the future of the code, things that should be made, features that should be implemented. So it's actually two things going on at once, the summits, and there's two of them each year. Okay, there's two of them each year. And so during that design summit, there's two design summits a year. During that design summit, they're talking about, for example, let's look at Grizzly in 2012. This is where they were planning the Grizzly release at the design summit. That's where they were planning the Grizzly release. They're planning and deciding what should be released. And then at the Havana, they were celebrating the Grizzly release while planning the Havana release.
Okay.
But you're right,
Yeah.
it's a specific version. Like on your Mac, you might have different versions, and you're gonna run an update, and then you're gonna get different features that are gonna be available within that version. That's basically what's happened each time. Like, you know, what's discussed during that summit is then implemented during the next, you know, development phase, and then they build all those features, and then they freeze it, and then they launch Icehouse, and then they discuss Juno, and then they freeze it, and they launch Juno, and then work on Kilo, and so that's the process. And so if you're an enterprise and you want to deploy OpenStack, right, you might be waiting for like a feature that's coming in Mitaka, so you might wait, and then you deploy Mitaka. And so when you hear people say, oh, I'm running OpenStack, it's like, oh, what version are you running? Oh, we're running Liberty, we're looking at Mitaka, right, because you maybe you're looking for a specific feature within Mitaka or something like that. But it allows you to freeze in time with just those features so that you can run it in production, right, because you don't want to run a ongoing open source project in production while people are adding features to it.
What could possibly go wrong?
I don't know.
So I
That's
was,
exactly what you do.
I was in the room with Rackspace. I'm one of the original contributors when NASA and us joined and we created OpenStack. And Austin was our way of trying to get all the external contributors to come in person and actually have verbal conversations. And that's what actually started the planning sessions. And that's where all this went. So,
Did you work for the company that Rackspace purchased?
so I was with Rackspace, then we bought SliceHost, I got grandfathered onto that team, and then that team merged with NASA and we created OpenStack.
Okay. But there was another company that was purchased right after that. That was doing the NASA thing. The guy with
Mosso
the
Labs?
beard.
Most of the labs was Rackspace Cloud.
Oh,
Yeah.
That's where I was.
Oh, okay.
Okay.
But SliceHost was the one we purchased, and that's what Cloud Servers was based off originally, as a Ruby on Rails. And then we all moved over to Python because the NASA team had written it all in Python,
Yeah.
and that's where we started.
I was at Rackspace at the time too.
It was awesome.
Cool.
Good old days.
It's a way to get all the nerds in one room and arguing with each other.
It's just an excuse.
That's what it translates to.
Any other questions at all? Anything? There are no dumb questions, so I don't want you to feel like this is an intro session. This is for if you don't know anything, so if you have any questions at all.
So,
Yeah.
sorry.
Don't say sorry.
What would, well, I guess, we'll go with more recent ones like Liberty and Mitaka.
Mhm.
What would be the, I guess, the new feature or the added feature from Liberty to Mitaka that would?
I mean, you may jump into a node repository, and let's say we fast forward. Let's say we go down to like September or something, and the cutoff for Newton, meaning you got to have a Newton branch by this date. They may not all have that branch at the same time, but more or less, you know, they're all going to be eventually. They're all going to be on that. They're going to cut that branch.
Okay.
And if you go into any OpenStack project, you go into Nova. Notice how the releases are here. Mitaka, Liberty, Kilo. I mean, the same thing goes for if you go into, let's say, Cinder. we'll see that there's cut branches in there too for those versions. See, and those probably, like for example, the Wataka one, probably more or less, I don't think it's on the same day or anything. I don't think that,
Right.
but it's more or
Okay.
less.
Yeah, I just wanted to know the dimensions.
Yeah.
Yeah, that makes sense.
Any other little questions before we jump into a little bit of the high level? We're not really getting into any nitty gritty sort of requirements for the exam today, but we will do an overview of the projects.
Maybe you're about to explain this, but the actual exam itself for the certification, which is just going to cover core, like it just wants you to know core, or is there a certain version that we should
Yes.
get into?
Yeah. So the exam is on Liberty release, and the exam was actually it's an all-in-one node. That is, you have access to the Horizon dashboard, and you have access to the terminal. And there's a series of objectives that you have to accomplish. And so, let me, how would I do a little review of the project, and then we'll do a little bit of high-level review of the exam, just so you know which projects are on the exam. Okay. So, let me show you this first. I haven't talked about the projects yet. I haven't talked about the projects, but if you were to go into an all-in-one node, and by all-in-one node, I'm talking about a single server that is running all of the OpenStack services. A single server that is running all of the OpenStack services. You may be thinking, well, can you do that in production? No. Typically in production, you're not going to have one single server running all the services. You're putting too much on one, right? Typically, you scale them out to multiple services. Actually, you know what? I don't want to start with that. I think it's too confusing. Let's start with this. Okay, there are three ways that a software developer that wants to actually develop an application on OpenStack, meaning they want to develop the next killer app, they want to use OpenStack to do it, there's three ways they can actually do that. Spin up VMs. The first way is the Horizon dashboard. This is the most user-friendly way to do it. You actually get a dashboard where you can actually click and create something. You can create a VM. You can create networks. In fact, I can actually pull one up for you really quick just so you can see it. If you haven't seen one before, let me show you. Gonna boot up here. Okay, here it is. Look, literally, remember we talked about that whole self-service aspect of it? Self-service, all you need to do is get the username and password from your cloud operator. Whoever that may be, the person who hired you, the IT guy, whatever, right? That's all you have to do, is get the username and password. So let's pretend for a second that I got my username and password. So I probably won't be an admin, right? I'll probably be a user. And I would be my user. And then I would say my password is my password, by the way. Very secure. And look, it's logging in here. There we are. So what you're looking at there is the Horizon dashboard. This is what it looks like. And it's not too fancy, but you can see here that as soon as you log in, you have this drop down up here. And these are all the projects that you're a part of. And you can think of projects as being like accounts. Like, for example, if I was a coffee consultant, and I worked for Dunkin' Donuts, and I worked for, you know, Starbucks or Pete's Coffee, all those different companies would come up in the top there. And as soon as I highlight that company that I want to be a part of, like for example here, my project. Oops, I don't have access to that. But you get the idea. When I click on one of those projects, I actually become part of that project. And when I'm part of that project, I can go and I can spin up instances. And instances are basically VMs. I can go to instances, I can go to launch an instance, right up here. I can say my instance, boot from image. You get the idea. So this is the Horizon dashboard. I would say it's a lot deeper than this, but you get a feel for what it's like, right? I can also create networks in here. I have object storage, that's Swift, which we'll talk about, and all that good stuff. So that's the Horizon dashboard. The second way I can interact with OpenStack is the CLI, or command line interface. This is actually a command line interface that you would just say different commands to do different things. So for example, if I wanted to boot a VM, I would just say nova boot -- flavor 1 -- image ubuntu my instance. And guess what? It would boot an instance just like that. Now you may be wondering, you didn't give it a username and password. How the heck is that going to work? Well, there's a special way to actually feed the client a username and password and setting it without having to put it in every time you want to do something. All right? Now, using the client, I can use the client from anywhere. I can use the client from my Mac OS X laptop. I can use it from a Linux laptop. And guess what? I don't have to be logged into my OpenStack environment to use a client. I could download a client on my Android device and spin up VMs from the Alamo Wi-Fi. The Alamo had Wi-Fi. I don't know if they do.
It's in the basement.
That's in the basement, yeah, TV. Yeah. So the client basically looks like this. I'm going to log into the box. I think I have the credentials on here. Let's see. Okay, I'm inside. And notice what happens when I run this command. Nova list. It's not going to work. That's a client right there. Nova list is a command that shows me all the running VMs in my environment. See what it says there? It says, I have no idea who you are. I need a username and a password. So you have two options at this point. You give it the username and password by saying Nova list -- like OS - username, your username, you put -- password, your password, you know, you put in all that information, URL that you want to actually authenticate against, you have to put all the information in there. Or you can simplify the whole process by just doing this thing called sourcing. And you source a file that looks like this. Let me show you the file. And I'm using the cat command. You know what that is? I'm just outputting the command here. Cat. Let's do the admin. It's a file that basically sets variables. My admin, my password, my project, that's my project name. That'd be like Dunkin' Donuts or what have you. My IP address of Keystone. As you can see, it's a local IP address, but guess what? If I were using the Wi-Fi at the Alamo, that would probably be an external IP or a name that would resolve to an external IP address, right? And then a region. And the region really isn't necessary, but if you're curious what that is, I can actually have my OpenStack environment in different data centers. And if I want to authenticate against something, if I were in Tokyo, I might want to use the Tokyo data center to authenticate or something. So that's what regions are for. And I'm going to go ahead and source, just to show you the client real quick. Source, credentials, admin. And that's going to provide the answers that the CLI is asking for. So watch. When I source as admin, look what happens when I say Nova list now. It works. It authenticates. And I don't have anything currently running. So that's how a client basically works there. That's how a client basically works. Any questions on that? I know it's a really high level, so some of you that are already are familiar with that, you're probably like, it's so easy, but if you're not familiar, it's kind of interesting, right? And the third way is via the API. The API, that's the actual API. Now guess what? As you can see here, you can see it's using the curl command. Anyone familiar with curl? Curl is that command line utility, right? That can talk a variety of protocols, but we typically use it for HTTP. And it works off request and response, just like the HTTP protocol, right? It's using the HTTP protocol to send a request and get back a response via that RESTful API. What do all these really use? What does the Horizon dashboard use, and what does the CLI use behind the scenes? What would you guess? The API. They all use the API behind the scenes. The CLI is just a really easy way for you to type a few simple commands, but in the background, all it's doing is running API calls. That's all it's doing. The Horizon dashboard is the same thing. It's just running API calls. Okay, so those are the three primary ways to interact with OpenStack. And then to go over just a few basics, if you're actually interacting with OpenStack and you want to interact with it via the API, what time are we done?
You're good.
No, what time are we done?
Whenever you're done.
Okay, let me show you this really quick.
Yeah, we usually do about an hour, but I mean,
Let me show you this real quick. Yeah, I don't
as long as everybody's good, I mean, this is awesome.
Keystone is identity. You saw me log into the dashboard. That's basically what it is. You log into the dashboard, username and password, it authenticates. What is authentication? It's just proving who you say you are. That's all it is. It's not authorization. Maybe wondering, well, what the heck really is authorization? And you hear people that are on that word all the time. Authorization is basically the idea of who can do what, who can't do this, who's authorized to do this, who can spin up VMs, who can spin up networks, who can see all the services running in the environment. That's authorization. Keystone doesn't care about who's authorized to do what. The rules as to who can do what are actually kept in the policy.json file, which is actually kept inside each individual project. So that's kind of the unique thing about Keystone. And Keystone does have this definition called a role, and it has a user, their role, the project they live in, but that's just a label. What really matters is when a service actually gets a token, which we haven't talked about, it gets a token, and then after it gets the authorization context for Keystone, it sees, oh, this person is part of the intern role. And then the project looks at its policy.json file, and thanks to the cloud operator said, man, that intern cannot spin up spin up instances, right? Because we don't want the intern doing crazy things, right? So that's more or less the way that works. Authentication, not authorization. If you want to install the client, this one's kind of old school. We really don't do this anymore, but this Python Keystone client, by the way, on the exam, all the clients are already installed, so you don't have to install any clients. The Keystone client's already on there, Cinder, Glance, all those clients. I mentioned that it was authentication, not authorization. It gives you a token and a service catalog. And if you're wondering what the service catalog is, all it is a list of all the services that the cloud operator has installed in the environment. And by services, I mean Cinder, Glance, Neutron. It's just like the map of like everything that you have to offer your people who are paying you lots of money to use your cloud, right? If you're trying to get rich off the cloud, the more services you have, the better. The more cool features you have to offer your customers. So if there's some crazy new service that comes out, that offers, I don't know, something like pizza as a service, you could go in the service catalog and it will actually say, pizza as a service, and it will have the URLs for how you can talk to that service. And then obviously you can talk via the raw API, you can talk via a CLI, if that pizza service has a pizza CLI, and it's a way of just offering up all these services to your customers. Tenants, projects, and accounts mean all the same thing. So when you see references to these, tenants, projects, and accounts, it means all the same thing. So it's really, really confusing, but they mean all the same thing. Just understand that with OpenStack, you get a lot of confusing terms because they change around stuff a lot. And here's an example of us separating our different customers that we have in our cloud via projects, but now there's a concept of domains, which is a newer concept, which on the exam you do have to create a domain, but it's not very hard. You have to create a role, you have to create a group, and I think that you have to create some users as well. Yeah. That's an example of the new domain structure. All it is a tier higher. If you're looking at this, the way to think about this is the first domain would be like Burger King, and inside Burger King, there would be these projects, and the projects would be like the HR department, the finance department, the IT department, and you'd have users inside projects within that one domain, and the domains are segregated, because obviously we don't want Burger King as in domain 1, we don't want them looking at the stuff inside McDonald's in domain 2, right? They're competitors. So that's what domains are, just a layer higher, so you can actually put projects inside. And then, let's see here, that was Keystone. And a few other ones real quick are Glance, which really are just images. So when you think about Glances are they're like hard drives on ice. They're like basically hard drives on ice. They're operating systems. We no longer do we go through an install, right? We're clicking next, we're looking at that blue send-off screen, or like that Ubuntu screen. It's like a snapshot. It's like a snapshot. So basically Glance just holds on to those snapshots that we have baked on our personal machines or baked with utilities like Image Builder. Glance just holds on to those images. So things like VMDKs, VDIs, ISOs, VHDs, QCal2, AMIs, RAW, and you can store those images in a variety of backends. So if you want to store those images in S3, every time someone uploads an image, you can store it in S3, you can store it in Swift, you can store it anywhere you want. And then Neutron, all Neutron is networking as a service. I say all it is, but it's super complex, but it provides an API to allow your users to create network subnets and routers. For example, a user would create a network, and as you can notice, guess who owns the network? Whatever tenant or project I'm a part of. I'm a part of Burger King, and I spin up a network, Burger King owns that network. Okay, and you might be thinking, well, what does the network do? Well, you need a network if you want to set up a VM, you get that VM connectivity to the net. We cleared a subnet here. So obviously you know that when you spin up a VM on a subnet like that, it's probably going to get something like 192.168.1.3 or something of the sort. Just like that. And then there's the concept of a port. And a port is just like connecting, like, think about your Ethernet cable or whatever. You plug Ethernet cable into the wall, or you plug it into your MacBook if you have the adapter. And what's burned into the adapter? A MAC address, right? And that's what you get right there. That's a port. And then obviously there's Nova, the most famous one. It's not one thing to know about that, it's not a hypervisor. It's not a hypervisor, it's just the layer of code that sits above a hypervisor. OpenStack supports a variety of hypervisors. Hypervisor, again, is what takes advantage of that hardware in order to spin up multiple VMs. In this case here, we have the Nova compute code, and it's using Hyper-V, VMware, and Xen on the left. And on the right, it's using Xen, KVM, LXC, QEMU, and UML on the right via libvirt API. And the last one here, or there's a couple more, but this is the most important core one, Cinder. All Cinder is it's like that portable USB drive that you plug in to your VM. Block storage. Very, very fast. Look, the reality behind all this stuff, code that talks Neutron, all that crazy networking stuff, it's just stuff that's built into Linux kernel. Okay, stuff like the IP Route 2 package. Okay, what do you think, just guessing, if you're a Linux person, what do you think Neutron uses for firewall?
IP tables.
IP tables. Yeah, exactly, IP tables. Exactly. So it's just Python code using, the real power really is in Linux. So that's the way I see it. And then of course, Swift is object storage. That's like your S3 or your Dropbox. Okay? Well, yeah, I really appreciate you guys having me and taking time to listen. If you come back in July, we're gonna be doing the actual review where we'll go down to the nitty gritty here. Maybe I'll even create some environments so you don't have to have the thing on your machine or in your, the virtual box. And we have Wi-Fi here, so we can SSH into a live OpenStack environment, and you can do things with it. So we'll actually get into the details, hands-on, how to study for the exam.
That could be cool. My only concern is I've seen some classes where everybody's trying to set up VirtualBox and get an instance running. Sometimes the first half of a day can be spent just getting everybody's environment set up. So that might,
You better
Be a good
SSH
idea.
to one. It's
Yeah.
just a lot of time.
yeah, yeah. Cool.
So that was SSH would be better? Yeah.
We can test it out too.
Yeah.
Yeah.
Cool. Yeah, and if you had any questions that you had, and I want to help you out with the vagrant question too, I can show you exactly how to map it out. I actually have, I think, an example of how to do it. If you want to stick around, I'm happy to show you. Okay, and any questions, I'll stick around too. So,
Cool.
thank you.
That's awesome.